Hello everyone. Now in this video you are going to learn how to draw the projections of a square prism when its axis is parallel to vertical plane and with certain conditions. So here you can see a square prism consists of two bases with four rectangular faces, and this is the upper base and this is the lower base, and four rectangular faces. You can see the axis of the prism is parallel to vertical plane. When the axis is parallel to vertical plane, the bases will be parallel to horizontal plane. The bases will be parallel to horizontal plane. And the first condition, you can see the edge of the base is parallel to horizontal plane and vertical plane. If you carefully observe this prism, it has four edges. AB, BC, CD, DA are the four edges of the upper base, as well as for the lower base 1, 2, 2, 3, 3, 4, 4, 1. Among these four, BC and AD are the two edges parallel to vertical plane, and BA and CD are the two edges perpendicular to vertical plane. You can see this one, edge of the base is perpendicular to vertical plane. So no need to draw individually. So when the two sides are parallel, the other two sides will be perpendicular. So for the two cases the projections will be the same. And also AD 4-1 is the one face, BC 3-2 is the another face. These two rectangular faces are parallel to vertical plane, and the other two sides are perpendicular to vertical plane. So the front view appears as a rectangle and the top view appears as a true shape of the polygon, that is square. The upper base is clearly visible, ABCD, and the bottom base is invisible. That's why kept the invisible one inside the polygon. Now the same I am going to draw. So take polygon, number of sides 4, edge method E, enter, switch on the ortho, 30. Yeah. Now eighty, 80, 80. Now this is the upper base and this is the lower base. We'll give the okay. Here you can see A, B, C, and then D. 1, 2, 3, 4. Yeah. As I said that this A1 is clearly visible, D4 is clearly visible, and the two edges B2 and C3 are invisible because these two edges lies beside to this one, behind this one. So when these hidden features are behind this one, only the visible lines will be considered. According to the priority of the lines, the first priority goes to the visible lines and then hidden lines. So that's why in the front view all the edges are visible. Okay, we'll give the notations for the front view now. So as I said, A is visible, B is invisible. A dash of B dash. Coming to the bottom base, 1 is visible, 1 dash of 2 dash. And here D dash of C dash. And here 4 dash of 3 dash. That's it. So here I'll write in detail. Sides AD and BC are parallel to vertical plane, and the sides AB and CD are perpendicular to vertical plane. That's it. So for this one, these are the things. And now when the edge of the base is inclined at certain angle to vertical plane, here you can see just we are treating any one of the edge 20 degrees to vertical plane. You can see here 5 degrees, 20 degrees to vertical plane. So now instead of drawing, I am copying it the same dimensions, right? That's why I am copying along with the notations. Yeah, Control C, Control V. Yeah. So now I'll draw. Okay. So as I said, this will be rotated. One of the edge will be rotated 20 degrees to vertical plane. So I selected all the things, rotate. So now I am taking A. You can take either A or B because I am going to consider AD edge, which is, and also BC is parallel to AD. So now I am taking A minus 20 because I am going to treat in the clockwise direction, minus 20. See, angular, because I chosen the point A, which is the hinge point. Perfect, 20 degrees to vertical plane. Now drawing the projectors. Yeah, I drawn the projectors from each and every corner as well as from the center of the polygon. And now axis is 80. It's better to draw lines only instead of copying. Now this is the upper base and this is the lower base. Okay. So if you see here, the edge B2 is clearly visible, D4 clearly visible, and A1, which is in between, very clearly visible to the observer, but the only one vertical edge, that is C3, is invisible because it lies backside to these 3. The same you can see here. A1 is clearly visible, D4 is clearly visible, C3 is clearly visible. The only one edge which is invisible is B2 because it lies backside to the this rectangular face. So now only this is the one which is hidden, so I am applying the dashed 2 line. Okay, and the remaining edges are visible. This belongs to the center line. Select, apply, center 2. Okay, now take this one, take this one. These are the visible edges. 0.4. Yeah, now let us give the notations. Yeah, this is belongs to A dash, and this is 1 dash, and this belongs to B, which is invisible, B dash, two dash, this is D dash, 4 dash, and here C dash, and this is 3 dash. So this is the only one edge invisible, that's why dashed line, center line. So if you want to make some more, see, LTS is already 1, so you can apply 0.5. Yeah, see, the lines get reduced. Perfect, still more perfect representation. Yeah, okay, so this is also a center line. I will apply center 2. Okay, now this is all about the first two cases, and now the last case is that when the edges of the base are equally inclined to vertical plane. If you see here, these edges are 90 degrees with each other, 90, 90, 90. So these two sides are 0 degrees and these two sides are 90 degrees with respect to vertical plane, and they are asking equally inclined to vertical plane. You can see the third case. Equally inclined means each side will make an angle 45 degrees with respect to vertical plane. So again, instead of drawing, I am copying it. Control C, Control V, paste it. Okay, now select everything, rotate. So I am choosing the point B, equal inclined 45, so 45, that's it. It moves up, just I'll lower it. Okay, so now I'm going to make the projectors. Eighty, 80, upper base and the lower base. So if you see, when it is inclined, equally inclined to vertical plane, this edge B2 is clearly visible and D4 is clearly visible. One thing is A1, which is also very clearly visible. That's why in the center we represented a thick line. See here, there is no edge, that's why dashed line. But when it is inclined, equally inclined to vertical plane, this edge will be visible. And if you observe one more thing, here the A1 is the one which is clearly visible, vertical edge, and backside to this one the center line exists, and backside to the center line C3 is the edge which is invisible. So in the same line we are having three different types of lines. One is a visible line, second one is the center line, third one is the hidden line. So according to the line priority concept, the first priority will be given to the visible line, second priority will be given to the hidden line, so third priority will be given to the center line. As of now, the first priority wise we are going to give to the continuous line, so that's why represented with continuous line. The same you can see here also, visible line, center line, continuous line. So first priority visible line, in that case everything will be continuous, there is no center line and hidden line in this thing. Point 4, yeah. Now let us give the notations. As I said, this will be the upper base B dash and the bottom base is 2 dash. Coming to the one, A dash is clearly visible, C dash is invisible, and now this is the lower one, 1 dash is clearly visible, 3 dash, and here D dash and 4 dash. Switch off the ortho. That's it. So let us give the dimensioning for everything. So height of the solid and the side of the base, the same height of the solid and then side. So this is all about the orthographic projections of a square prism when its axis is parallel to vertical plane along with the conditions for the edges of the base.